and welcome back to Hadoop Exam Learning Resources. In this video session, we will cover now next question from our Databricks Spark Developer Certification Simulator, which is on based on version Spark of 2.x, and we have already discussed few of the questions from our simulator. So like 7 or 8 we have already discussed till now. Our focus is on more of the fundamental concepts as well as the programming questions. Okay, so this is selected questions only we will be discussing in this video, and we have in total 360 questions in our simulator, and we will be keep updating our material, so it may increase in future or may decrease even based on the feedback and syllabus change. We would keep doing the things, correct? So let's start with this session. In this section we will discuss and focus more about the one of the my favorite topic in this part is this broadcast variable and the accumulator. So certainly you would get one question of each, one from broadcast variable and one for accumulator. So you need to understand the concepts of both. So let's start with the accumulator in this video and related question. So this is the question which I'll be covering here. You have been given the below Spark code. Hadoop exam RDD represent 100 records from a file. Okay, there are 100 records which are loaded in this RDD, and there's a accumulator object is created using the Spark context, which is initialized with 0, and it has been used in the map functions to increment as each record is read. So what would be the value of SCC, this is accumulator, once the entire Spark job is finished? So there are 4 options given: 100, 101, 0, and it cannot be predicted. So let me explain you little bit before moving ahead with this answers. So concepts we need to clear it first. Okay, so let me clear it out. So accumulator is the variable which actually when you submit a job to a cluster in the Spark, correct? So accumulator variable can only be changed or updated by the task on the worker node, correct? This variable can only be changed or updated by the worker node, and driver program can only collect the accumulator from each node back. Suppose here accumulator value is 5, here accumulator value is 9, here accumulator value is 11, here accumulator value is 12, something kind of thing, correct? So it would give you the final result is their total value of the accumulator is 27, correct? So 9, 5, 14, 11, 25 and 2, 27, correct? So this is the final value. So driver program will not update the or change the accumulator value. It will collect the values from each node and give the final result. But now the problem here in the given question is we are using the map function, and inside the map function we are using the accumulator variable, and as you know map function is a transformation, correct? And this transformation can be executed multiple times. If this node fails, then this executor can be or transformation can be executed on this node for the same data. So let's discuss the our explanation which we have for these questions. Okay, so correct answer here is if you are using accumulator in transformation, then you cannot predict the what will be the final value of the accumulator. Reason we will discuss is, let's know the details about for the accumulator updates perform inside the action or should be performed inside the action only. Okay, you can do in transformation, but it should be done in the action. Spark guarantees that each task update to the accumulator will only applied once if you do in actions. If you do in transformation, then Spark cannot give you the guarantee how many times a accumulator would be updated. So restarted task will not update the values. Okay, okay, let's say In transformers, users should be aware of that each task update may be applied more than once if the task job stages are re-executed. Correct? Stages we have discussed in our previous video. Stages, task, and job. You now you understand what I mean here. Hence, in the given code, there is no action. Hence, value of the ACC is not incremented and initially remains 0. In transformation, it may change. Okay, and even if you are using accumulator in the map, which is a transformation, hence their final value is not reliable. That is what they wanted to say. So what are the cases which we wanted to discuss? Suppose let's assume a task failed due to some exception in the code. You have written some code which causes the X task to be failed. Spark will retry the same task 4 times. If task fails every time, it will give an exception. If the by chance it succeeds, then Spark will continue and just update the accumulator value of the successful state, and failed state accumulator would be ignored. So this is very well handled by the Spark. If task fails multiple times, and then only accumulator value where the task success would be considered by the Spark. So that is where the Spark applies the intelligence. So that is fine. Stage failures. If entire stage failure, a stage can have a multiple task, we have discussed, correct? If an executed node crashes, no fault of user but an hardware failure. And if the node goes down in shuffle stage, okay, if data is being shuffled, a shuffle output stored locally. If a node goes down, that shuffle output is also gone. So Spark goes back that stage and generate the shuffled output again, looks at which task need to be rerun and execute them one of the nodes that is still alive. After we regenerate the missing shuffle output, the stage which generate the map output has executed some of its tasks multiple times. Spark counts the accumulator updates for all of them. Okay, so this situation is not handled very well in the Spark, because you are in between of the node and in your cluster, and this node suppose goes down, then whatever some accumulation has been done or something incremented, then still send, maybe in between send to the driver, it has been sent to the driver, so that can give you the wrong count. Okay, if the next condition, if a task is running slow, as you know, speculative execution, we say Spark launch speculative copy of the task on another node. Suppose some reason this hardware is very slow and there is no capacity to give you the good speed. Spark does, same task will start on another node with the same partition of the data. It will copy here and start working on this data in this node. So whichever finishes first would be considered here, but in between it is possible like your accumulator value on this node also incremented and on this node also incremented if you are using in the transformation, because you are doing this activities in the transformation, correct, which can lead to a wrong output. So RDD which is cached is a huge and cannot reside in memory. So whenever the RDD is used, it will run the map operation to get the RDD. And again, if you remember in the previous session, we have discussed about this here when we load the file. Okay, you go and watch the previous session to detail. Okay, so if I click on this stage, you see here whenever file read from somewhere, it use the map operation. Okay, this CSV file would be read, so it would be using the map operation. Okay, here you can see here, this is the map operation, correct. So what we are saying is, and we'll run the map operation to get the RDD, and again accumulator will be updated by it. So not handled accumulator will, and in this case also cache, when you cache the RDD and persist it on disk and reload the data, again accumulator would be considered. So the better solution, if you want the correct accumulator value, then always use the accumulator in action. So in the real exam you would certainly get a question based on the accumulator and broadcast variable, and this concept might help. So we have a lot of question based on the accumulator and broadcast variable in our simulator. So this is the simulator which contains 7 question paper. Here you can see Each question paper has approximately 60 questions. Last paper will not have all 60 questions, it would have only 17 questions, but 360 plus 17 questions, so you can say like approximately 376 questions this simulator has. So once you complete all the questions, it will not help you in the only in the exam of the certification, but also you would become master of Spark, because we have covered a lot of coding questions and fundamental concept of Spark. So keep visiting adobeexam.com. We are keep updating our materials, we are keep adding new materials, we try to provide as much as support as possible with our material, so you can succeed with your job as well as your certification exam, so you can build your career in a particular technology or domain with the help of Hadoop exam. So we have various technology and we are keep adding new things. So I suggest you subscribe here to get the regular updates. So you just put your name and email ID and we will send you the alert. And you have we have our most popular project, which is annual subscription. So whatever we add in the new things entire year, you would get without any cost in as part of the training. So most of the trainings are covered in our annual subscription, so you can check what all are covered in the annual subscription. So we have couple of books as well as of now in this annual subscription, and these are the various trainings in the our annual subscription. So thanks for watching, and I hope you like this session. We will discuss further more questions on this Databricks Spark 2.x certification. Thank you, and please if you are watching on YouTube, don't forget to subscribe it.